In this video, we're going to be working on a review for the Module 4 exam. So you can see problem 1 here. It says solve, which is kind of how my math lab will give it to you. They'll just give you a basic direction. They're not going to give you a lot of notes on what to do. So you're going to have to know that when you're given this, where to start. First thing we need to do is to multiply. We need to FOIL this left side. That way we can then move this number over. So we'll start by FOILing. X squared minus x plus 3x minus 3 equals 4x. Now I want to combine like terms. So I get x squared minus x plus 3x gives me a plus 2x minus 3 equals 4x minus 4x from both sides. I get x squared minus 2x minus 3 now equals 0. So once it's equal to 0, now I can factor and then set each of the factors equal to 0. So I want to see what can multiply to give me a negative 3 and add to give me a negative 2. Start by filling in what you know. We're going to have an x in each one. The only way to get a minus and a minus is a plus and a minus, because a plus times a minus would give me a negative, and 3 is prime, so we only have 1 and 3. And we need our larger number to be negative because our b term is negative. If we FOILed this to check, we'd get x times x is x squared minus 3x plus 1x minus 3. Negative 3x plus 1x gives me the negative 2x, so that's good. Right, so now we have it factored. And the zero property rule says that in order for something times something else to be equal to 0, either the first thing must be equal to 0 or the second thing must be equal to 0, right? So either the first number or the second number must be equal to 0, and then you solve. So x is equal to negative 1 or x is equal to 3. It's a set that contains negative 1 and 3, right? Okay, so same thing. Solve 3x squared plus 5x minus 7 equals 3 minus 8x. This time we don't have to do any FOILing, but we do need it to be equal to 0 again. The only way you can solve these quadratics or for an x, you need it to be equal to 0. So minus 3, 3x squared plus 5x minus 10 equals a negative 8x plus 8x plus 8x gives us a 3x squared plus 13x minus 10, right? And so from here equals 0. So from here now we have to factor. We can do guess and check, or we could do grouping. We're going to just do a quick review on grouping. Grouping is where I take A times C, so 3 times 10 gives me 30, and I look for factors of 30 that can combine to 13. So I have 1 and 30, 2 and 15. 2 and 15 might work, but my signs with this being a plus and this being a minus means they need to be plus minus, right? So that would work. A negative 2 plus 15. So now I rewrite, because there's only one set that would work, right? You might have seen 3 and 10, but 3 and 10 would only work if they were the same sign, if it was plus, and they're not. So 3 and 10 will not work. It has to be negative 2 plus 15. And now I rewrite this 13. So I write 3x squared minus 2x plus 15x minus 10 equals 0. And if I look at my negative 2 plus 15, if I combine these two, I would get back to my plus 13 that I started with. You need to make sure that these two don't change this number. If they did, then it would be incorrect. And now we do grouping. We look at the first set and we look at the second set. First set, what do they have in common? Just an x. Pull an x out. I'm left with 3x minus 2. 15x and 10 have a 5, so plus 5. Again, if you want to think about this like you're dividing out whatever it is that you take out, so 15 divided by 5 gives me 3x, minus 10 divided by 5 gives me 2. Still equal to 0. Now they each have the 3x minus 2 in common. And the x plus 5 is what's left, is equal to 0. And now I set each one equal to 0. I strongly recommend that you don't skip this step. A lot of my students do skip this step and then they make a mistake. They have a sign error or something silly because they're rushing and they think they don't need to write this step. So I strongly recommend that you do write it. Solve each one for x. So x equals -5. So the set of 2 over 3 and -5 are two answers for this solution, for this equation. Okay, so looking at number 3, it says find the domain of the rational function, and then it says c of x equals x plus 2 over x squared minus 25. So I'm just going to go ahead and rewrite this c of x equals x plus 2 over x squared minus 25, right? And so this is my rational function, and when we're talking about a rational function, it's something that's a fraction, right? And so when you're looking at this kind of a function and you're trying to talk about domain, you're saying, what can x not be? What can I not get from my x, right? And what we're really concerned with when you're dealing with a fraction is getting 0 in the denominator, right? Because we say this is no, it's undefined. Anytime that a fraction has a 0 in the denominator, it's not okay. So what I want to do is look at the denominator of my fraction and say, when would this equal to 0? And solve from there, right? So hopefully you see this and you say, oh, it's a difference of squares, right? X plus 5, x minus 5 equals 0. X plus 5 equals 0. X minus 5 equals 0. Solve each of these for x. So x equals -5 and x equals 5. That means that x cannot equal -5 or 5. Because if I take -5 or 5 and plug it in, right? So if I say 5, c of 5 equals 5 plus 2 over 5 squared minus 25. I would get 7 over 25 minus 25, which is equal to 7 over 0. And that is undefined. And the same thing would happen if I plugged in -5. So those are both answers that or x's that we cannot choose. They're not an eligible x, right? So we want to say that x can be any other number except for -5 or 5. I can put any other number in and it's not going to give me 0 in the denominator. But -5 and 5 will both give me 0 in the denominator, right? And so I think we use set builder notation. We say x is a part of the set and x is a real number. And x does not equal -5 or 5. And my math lab generally just has the box right here, right? They just want you to put in these two numbers. But it's important to kind of know what this says. It says it's a set that x is a part of the set and x is a real number and x does not equal to -5 or 5. You won't have to write this whole thing out in this class, but you may have to do it in a future class. Okay, so this one says simplify 9mn plus 8m minus 9n minus 8 over 4mn plus 7m minus 4n minus 7. And this is one a lot of students get tripped up on. It's kind of big. There's not a lot of direction. It just says simplify and you're expected to know what to do. So hopefully what you see is that there's not a lot I can do. I cannot start canceling stuff right now. There's nothing really that cancels. I could rearrange the terms, but I can't really combine anything because there's no like terms. So my only option is to do grouping. Okay, so I'm going to rewrite the whole thing. And first look at the top, right? And anytime it's a negative, like a negative 9n, I include it in the parentheses and then I write a little plus there. So I want to first look at this first set, 9mn plus 8m. What do they have in common? Well, they both have an m. So I'm going to pull that m out and then I'm left with 9n plus 8. Here, the second set, I have negative 9n minus 8. Hopefully you see that they have a negative 1 in common, which gives us 9n plus 8, because you're taking a negative 1 out of each one. Do the same thing on the bottom, right? So on the bottom, the first two both have an m. 4n plus 7 minus 1, again, they both have a negative sign. So 4n plus 7, okay? I do have students sometimes that are inclined to want to try to cancel these m's out right now. We do not want to do that. We want to finish our grouping process, right? Which is where we say now the top both have this. So I have 9n plus 8 times m minus 1. And the bottom one both have a 4n plus 7 times m minus 1. Now we have an m minus 1 over an m minus 1, and they cancel out, and we are just left with 9n plus 8 over 4n plus 7. Okay, so this one says perform the indicated operation, and you can see this thing's kind of big and ugly, but we're going to take it in bite-sized pieces, right? Just do one piece at a time. So we want to start inside the parentheses, c squared minus d squared all over c squared plus d squared divided by c squared minus d squared all over 6c times c squared plus d squared over 36, right? And so first thing we want to do is start factoring. You can go ahead and flip this for the division if you'd like to. So we'd write it as c squared minus d squared over c squared plus d squared times, because remember we do keep, change to multiplication, and flip the last fraction, right? And this is just what's inside the parentheses. We're not even going to mess with what's outside the parentheses until we finish in the parentheses first, okay? So you could factor, or hopefully you see that you have a c squared minus d squared and a c squared minus d squared. So these go ahead and cancel out. C squared plus d squared is not factorable, and 6c is not factorable. So now my numerator is 6c, and my bottom is c squared plus d squared. Now I bring down my multiplication, times c squared plus d squared over 36. Here again, I have a c squared plus d squared and a c squared plus d squared, so they cancel, and I'm left with 6c over 36, okay? And now I do need to go ahead and simplify. 6 over 36. 6 goes into 6 once, so I just have c, and into 36 6 times. So c over 6 would be the final answer for that one.